To add a new track piece, under the track parameters, click the New Track button. This creates a new track piece attached to the existing one. Shape this track section by editing the spline's control points. Each new track section starts with only 2 control points, but we will add more to build the track section we want. This will be the pre-lift track that gently slopes down and makes a right turn into the chain lift. Notice that the track is making the 90-degree turn right at the control point. This is a result of the order property being set to 2. Under the Active Spline Properties panel, increase the order property to smooth out the spline. Now adjust the curve until satisfied with the track's path. This section is almost done. We just need a catwalk from the station to the lift hill. In track parameters, there are buttons for adding both right and left catwalks to a given piece of track. Next, we will be creating the chain lift. Add a new track section and begin profiling the lift hill using the control points. This is the same process that we used for the pre-lift section of track. Preferably, you want the least amount of control points for creating a given shape because it makes editing the track later easier. That is why the control points will be grouped at each end of the lift hill defining the sharp curve, and less along the relatively straight section of track, the lift hill. Also, the Active Spline's order property should be increased for smoothing the track. Having a greater number of control points at the lift hill's base can help produce a quick transition from the level piece of track to the desired incline. The top of the lift hill is important because it determines the end of the chain lift and consequently where the train cars separate from the chain. I will check that the track sections are aligned. Introducing track roll can cause one end of that track piece to not line up with the previous piece. Currently, all 3 sections, station, pre-lift, and lift, do not have any track roll, so they are still aligned properly. The track type should be changed from standard track to chain lift. This informs the coaster builder that this track section is chain lift and will affect the roller coaster's train's motion accordingly. Also, it enables the track-specific settings, such as chain speed and the Add Chain button. We will now add a catwalk on both sides of the lift hill. The catwalk changes from a flat surface on the pre-lift to stairs on the lift hill based on the angle of ascent. Currently, catwalks do not work with track roll. Next, we will construct the main track section of the roller coaster. Starting with the main drop, we will adjust the spline's control points until the profile looks correct. At this point, we will not worry about the track's roll axis as we will fix it later. The spline's location is all that we are currently concerned about. To create believable track layouts, the coaster should only experience G-forces within the acceptable range of people riding. This means that making too sharp of a turn at high speed, incorrect track banking, or excessive negative G-force over a hill can cause the roller coaster to look unrealistic. That is why you should consider the forces acting on the train and the riders throughout the layout. As always, it is beneficial to study actual roller coasters and use reference photos for the different elements. Continue this process to create the remainder of the main track section. If the viewport frame rate drops while editing a long spline, you can switch the scene to Edit Coaster and lower the preview resolution of the spline temporarily. This scene does not contain the track mesh, making it more responsive, but with the drawback of not displaying the tracks roll. The main track section's roll no longer aligns because of the minimum twist method. To fix this, use the track tool, Fix Track Roll. This can alter the roll of the entire track section. That is why you should perform this before adjusting the track's roll. Each track piece has empties for controlling roll, one that is attached to the end of the track and another that specifies the target roll. If the target roll empty is changed, the Fix Track Roll button needs to be pressed again to realign the track. Once the track section is correctly aligned to the previous, now we can edit the track's roll. The last track section is the brake run. Select brakes from the track type in the track parameters and click Add Brakes. Next, I will set the target speed to 2 and force to 7. The target speed is the maximum speed that the brakes will allow a train to travel through the section of track. The force variable sets the force applied to each train car while exceeding the target speed through the brake run. This last section completes the circuit requiring the end of this piece to attach the beginning of the station. The minimum number of control points of a track section is 4, because each end of the track must align tangentially to the adjacent pieces. The coaster builder uses the control points next to each end for alignment, making fewer than 4 control points per track section to cause connection problems. Place the last control point of the brake run at the same location as the start of the station. The Connect Track End button completes the circuit by combining the roll targets of these 2 track sections, allowing the Fix Track Roll tool to work as expected. Also, add a catwalk along the right side of the brake run. Before calculating the train's physics, I will perform the final edits to the track roll. Do not forget to increase the track's resolution after editing, or the train's motion will not be as smooth. Also, remember to add the chain to the chain lift. Unlike catwalks, the Add Chain Lift button generates a separate spline for the chain that is not linked to the lift hill. This means that for future edits to the lift hill, the chain will have to be removed and generated again. Once done tweaking the track's control points, press the Calculate Physics button and wait for it to finish. This saves the train simulation data to keyframes. Verify that the coaster's motion is as expected. If the train valleys or runs excessively fast, you may have to reprofile the track or adjust the wind drag setting. After attaining a satisfying result with both the track layout and the train's motion, we can now create the support structures. Under the support collection, there are 4 types of supports. Duplicating the collection and setting the target to the desired spline makes the support visible. There are empties for adjusting the location of both the base and top of the supports. Adjust the cube-shaped empty offset to slide the support along the track. Duplicate the newly created support and slide it along the track using its follow path offset. For a single support beam, these empties should only be altered vertically to maintain proper contact with the base and limit unnecessary mesh distortion. Repeat this process of duplicating and modifying the location of the single support beam along the pre-lift. Transitioning to the next track section requires the follow path target of the support to be retargeted to the new track section. The supports will automatically lengthen from the base to the track height, but some editing of the top beam empty will be needed for steep track angles. The next type of support, Support 2, has a second support beam that can be positioned off to the side. The beams are slightly larger and are suited best for medium to large hills or high-speed turns involving intense G-forces. This is the most common support structure on this type of steel roller coaster. Next, the large A-frame support has more empties for adjustments, one at each end of the support beams contained in the structure. These are adjusted by their respective offset sliders so that they remain attached to the two main support beams. These large A-frame supports are primarily used on tall lift hills. The center empty between the two main support beams adjusts the target angle of the support attach point at the top. Getting the right distance between supports and the support beam angle is important because otherwise something about the coaster will look off. Again, reference photos are a great resource in understanding where supports are placed and how they transfer the train's forces to the ground. Duplicate the desired support types and change their offsets along the track to complete the coaster's support structure. There is one more type of support, an inverted support. It has the main support beam off to one side, allowing the track to be upside down beside it. This support is similar to the second support, with one straight beam into the ground and another at an angle connecting at the top. that is how you create a roller coaster from start to finish using Zero G Coaster Builder. Now we can preview our working roller coaster.